Hello everyone, welcome to DevOps and Data Simplified. In today's video, we are going to take a look at a crucial topic, end-to-end SSL. You might have probably heard about SSL already, but what does end-to-end mean? And why is it so important in today's complex infrastructures? Stick around, because by the end of this video, you'll not only know how the end-to-end SSL works, but also understand how it secures your data from start to finish, no matter how many intermediate hops your communication passes through. Please note that this is a theoretical approach of the end-to-end SSL concept. I'm creating a playlist, so make sure you check out the next video in this series for the hands-on approach. So let's dive right in. Let's start with the basics. SSL, or Secure Sockets Layer, is a protocol which is used to encrypt the communication between two different systems, often a web browser and a server. Over the time, SSL evolved into TLS, Transport Security Layer Protocol. However, for the sake of simplicity, we will use the term SSL in this video. Now let's focus on end-to-end SSL. This is where the distinction comes in. Often, in most of the setups, you have one client and one server, and SSL is responsible to encrypt the traffic between client and a server. But in complex infrastructures or microservices based infrastructures which are deployed on the cloud providers, most of the times there are few intermediary hops that are involved, such as load balancers, app gateways, and proxies. End-to-end SSL means the data is encrypted throughout the entire journey, from the client to server and across all the middle hops. This means the data will remain encrypted, and this will make sure that there will be no one reading or tampering with your data. In traditional setups, the SSL might be implemented between client and load balancer, and what happens beyond load balancer may remain unencrypted. This might cause vulnerabilities. In today's application architectures, the data could be divided into multiple microservices, and data could flow from multiple layers. Without the end-to-end encryption, any of these layers could pose the vulnerabilities. With the end-to-end SSL, we ensure that the data is encrypted across every single layer. This is especially crucial in the cloud environments where data could flow through multiple processes and nodes. Think of it as a continuous shield around your data from browser all the way to the backend servers. SSL certificate validates the identity between the communicating parties, preventing the man-in-the-middle attack. It ensures that the data which is sent from the client to server has not been tampered with throughout the transit. And of course, it is compliant across many standards like GDPR, HIPAA, NIST, SOC 2, etc. Now let's get into how it actually works. The core of SSL encryption lies into a handshake. First, the client, usually the web browser, sends a client hello message to the server telling it what encryption algorithm it supports. The server responds then with server hello, sending its certificate to the client, which includes its public key. Then the client and server exchange the keys based on the agreed upon algorithm. And once the handshake is complete, all the communication between the client and server is encrypted. In case of only the front-end SSL or a non-end-to-end SSL, the communication is encrypted till the first hop only, usually the load balancer, and then the SSL gets terminated at the load balancer level, resulting the traffic beyond the load balancer to be remain unencrypted. But here is where the end-to-end SSL comes in. When the hops like load balancer or API gateway are involved, the communication through those hops also remains encrypted. The hops will not be able to read the data, and this is achieved by implementing SSL encryption at every hops level. Now, how do you really implement the end-to-end SSL in the real-world systems? In the modern architecture like Kubernetes or cloud providers, here are a few steps that you need to follow. Using the SSL termination at multiple layers in the system. Start by ensuring that the SSL termination is happening across every layer of the system, including API gateways, load balancers, even in between the microservices. Automating the certificate management. Managing the SSL certificates manually can be challenging, especially in the complex systems. Tools like Cert Manager will help us in issuance and renewal of the certificates using the services like Let's Encrypt, etc. This basically ensures that the security is implemented without any hassle. Mutual authentication. In some cases, both the client as well as the server needs to authenticate each other. This adds an extra layer of security and can be really helpful in especially the internal communications where the communication is happening in between the two different services. And of course, implementing the end-to-end SSL comes up with its own set of challenges, especially the certificate management in case you are implementing the certificates on multiple levels. So here are a few best practices that we can go through. Automate everything, whether it is the certificate renewal, configuration, or the deployment. Automating your whole SSL setup can be really helpful in saving your time as well as reducing the mistakes. Make sure you automate the rotation of the certificate so that you are always using up-to-date encryption. Use of mutual authentication. For highly secure environments, make sure that the client and server both are authenticating each other. This can be done by configuring the SSL at the both ends. Always stay on top of latest security and patches related to SSL or TLS. In summary, end-to-end SSL is the critical part of the modern infrastructure, ensuring that the data remains encrypted across all layers of the communication. Whether you are managing microservices, APIs, or any other kind of cloud-based system, end-to-end SSL helps protect your data as well as users. Thanks for watching. I hope it helped clarify what end-to-end SSL is and why is it so important. Don't forget to hit the like and subscribe, and do share this video with your colleagues and friends. And if you have any question, make sure to drop them in the form of comments. And I'll see you in the next video.